pretty bad lava then, but nobody can cross except the bird. Or you can try. So these are the first hours, and then usually the discharge rate drops down to. That's close, they are getting annoyed. We have in Iceland 4
You're not a hammer. Here. Spool.
And then it squeezed up in.
Oh yeah,
Yeah, here too.
yeah. So like it like crusts and then flows around the crust and wedges itself in. Probably expands and cracks.
That was in the TRR, right?
You're not specified to members in volcanic.
Oh, that's perfect.
That is so cool.
And red seams.
Red triangle.
Yes.
I think it's like
Ron. I can't see where those continue on this side.
This is very interesting.
Yeah, I think you want this or
So in your pilot.
Should there be like 2 colors that go into one eyelet? I mean, like.
Yeah, there are a couple of people, especially red.
this is like way strong. And Angela?
Yep. We're gonna go above the door. Above the door and then underneath the window.
Whoa, I know, yeah.
That's what I'm going to do with the mustard.
Whoa.
Yeah. Oh, you mean Nutella? Use my turkey as a Nutella? I would sacrifice a slice of turkey for that. To be the Nutella holder. I think we have one lighter.
Because it's like a nut spread, but also
bunks do have pads on them.
Do you remember that stuff called like
There's a line on the
dude side?
dude side.
Dang.
Morning coffee.
Yep.
Over here.
Oh my goodness, I'm very excited about this creation.
Lunch. Sandwich plus
Snackies.
snack and.
Is it you want to call us?
Just in case we need to call you for.
Okay. Okay. All right, I'll turn it on.
And the code is 1123.
All right. Just a couple quick items and then we'll be on our way.
The sat phone is in here. This front pocket of my big bag here. I'm gonna turn it on.
While you're powering it up, I want to ask one additional question. Your med kit that has your
It's at the bottom.
med list. Okay, great. Thank you.
So the sat phone is on. Okay, if you come here just real quick. So we just left Dreckie, the red dot, and we're going to number 1. When we drove out, we drove right past this big finger of lava flow. Right in front of us is the rest of that lava flow. I think the key features that we can see here is right here, this really big hill. And if I bring you over to this map here, so that's where number 1 is, that's where we're going. But there's some stuff over here, some higher elevation over here. So this makes sense, but we're kind of going between the lava flow and those mounds, kind of what I expect to do. And then when we get to where we want to be right between the huge large feature and the lava flow. So a line from the big, large feature to the lava flow, and that's this one here, kind of the far side of it. All right, we're just suiting up here to leave on our 2-day trek, and we're gonna go explore a bit Iceland, maybe a few volcanic features. I'd like somebody to volunteer to just follow the trail, and then I'll kind of keep my head up.
And are we all agreeing that we're going to that next post?
Yeah. Okay. Yep.
Note, the last time we will agree.
For last time. Trail that they're gonna. Oh, that's a topo line. Okay.
What's the yellow?
Yellow's the road. The orange is the topo line.
Ah.
My name is Trevor Graff. I'm an exploration geologist, part of the Artemis science team, where I am the hardware and testing lead, and for Artemis II, I am one of the science officers. This week we're here in beautiful Iceland, training the Artemis II crew and planning for our future Artemis missions out here. It's a fantastic place here in Iceland to be able to train geology. Also navigation skills are another big component of what we're doing out here. And then also getting some expeditionary skills as we learn to live and work together in a beautiful environment like this out here camping in the highlands of Iceland.
Or do one from each pair.
That's what I was just thinking, one from each pair.
Like there's some strategy there, but like there's definitely a lot of content that we're trying to prep them for their success in the capstone.
Of those options, so there's the primary, right? It's on the table, just execute as we plan. Given that it might be spitty and weathery and stuff like that, but so that's an overarching thing.
My name is Kelsey Young, and I am the Artemis Science Flight Operations Lead and the lead for lunar science on Artemis II. We are here in Iceland training astronauts and training other Artemis personnel in field geology. So we're going to be exploring the volcanic deposits, teaching them how to explore a station when they're doing EVAs on Artemis, and also how to make good observations when they're passing by the moon on Artemis II. Astronauts have been to the moon, of course, with the Apollo program. We conducted a lot of wonderful science. I'm a geologist. I love to think about all the science we've accomplished with lunar exploration. But we went to a pretty geographically and geologically constrained part of the moon with the Apollo missions. On Artemis, we'll visit the lunar South Pole. We'll make observations from orbit. And we have a whole new set of science questions that we hope that Artemis astronauts will help us answer. We hope to learn about the evolution of the moon. But actually, a lot of the objectives that those astronauts are going to be doing will tell us about the evolution of our own planet and the entire solar system.
My name is Cindy Evans. I'm at the Johnson Space Center. I'm the geology training lead for Artemis.
Awesome. And what are we doing here in Iceland?
In Iceland, we are doing field work. We're training crew members. This is a key location for training for Artemis crews. We are both scoping out all of the field sites, all of the training objectives, making sure that they jive with our classroom objectives. We're practicing and we are delivering training to the Artemis II crew. We're also getting all of our logistics down. So the next time we do this, everything's set. Iceland is a great analog for the moon in a bunch of different ways. It's got the planetary processes, in this case volcanism. It has the landscape. There's no vegetation here. It looks like the moon. It has the rocks, that both volcanic rocks, basalts that we see on the moon, and also volcanic breccias that are an analog for breccias on the moon. And it has the scale. It has the scale of features that astronauts will both be observing on the moon and exploring on the moon.
I'm Angela Garcia, and I'm a geologist at NASA Johnson Space Center, and I'm here in Iceland training the Artemis II crew in geology, and I'm also an Artemis II science officer.
welcome to a true Icelandic day. Right? Like, yesterday was a treat. This is what to prepare for, at least for the next 2 days. And also welcome to Phase C. So we're officially in that science gear that we changed this morning.
The forecast is off and on rain, so this is probably not going to be constant all day. It's going to be sometimes it's going to be clear up, sometimes it's going to rain a little heavier. So that means, of course, rain gear. If you've got a bag cover, it's good to get on your stuff. What we worry about is hypothermia, and if your hands get too wet, they start to peel a little bit, wet feet, that kind of stuff. So
On the things, as Kelsey just said, differences in scale. You're going to be seeing volcanic products in different forms. The more you see, hopefully the more you feel confident in your geology skills. And the second thing is, we really want your feedback on how all these exercises go.
Getting to know the station, looking at rocks, maybe picking up some stuff in your hand and looking at it, just kind of getting familiar with what you're seeing. And what we're looking for at the end of that like little mini station walkabout is an awesome description. And so that description toolkit, Jacob and I are going to help you build over the next 3 hours.
Like a shark, but in Icelandic. Yeah.
I'd love some chocolate, but that's not happening.
Thank goodness I had chocolate last night. But plain could mean something totally different. So I would want to say like flat, extensive area with like abrupt features of different colors coming up. I can see some of them rubbly.
Yeah.
As I move over here.
There seems to be some kind of connection, but there's definitely some contrast.
Both outcrops.
Does this stuff seem to, it's not a bunch of the same stuff just pulverized though, there's like the gold to the black.
Agreed. Like the gold is not something I'm seeing in the outcrop. Yep. Okay. Alright, so how about we work together to generate a description? So any crew members want to volunteer to start to give a description?
Some different morphology on both sides on each finger of that U, and specifically the one we're talking about, the morphology is a little less angular.
Very distinctive flow characteristic to them.
Nice. And if you guys remember from like lunar fundamentals and maybe even ASCAN geology, is something in situ or not is really fundamental for us to understand, because it tells us something about a lot about how the terrain formed underneath our feet, or if it's something that could have like come from distance.
One thing that you said that was great was that it was sort of on-lapping these in situ boulders, these in situ outcrops. That's fantastic. What does that tell us about stratigraphy? What came last? What came first?
First class.
Done. That simple science changes humanity's perspective about the moon. 100%. So we know that it's under a kilometer of less dense rock, which we call ice, and that's still a lot of pressure. You know, I don't know how many of you have picked up a kilometer of ice before. I haven't. It's heavy. Under all that pressure, there's
With the water feature in it. Yeah.
This stuff here, just to come back to before we walk away. The only thing that's kind of different to me is how it's eroding here, or friable, or whatever.
Shaly.
Something, yeah. That's
Yeah.
it, shaly.
Yeah, like, and it's only one of the layers though. running through actually about the center of the science site is but in the same area as those outcrops is a fin-like structure that's about 1 meter-ish wide at its widest that is eroding differently than the outcrop around it, and a phase of salt that's like almost as synonymous with igneous. Yeah, because there's just not, there's no...
Looking at this big outcrop, we notice a dark unit at the bottom that's very consistent, dark gray. It has some waviness and bumps to it, and it kind of rises up in elevation as it comes out to the end of the outcrop. We also notice some other layers that are tan/brown in color that come in up above that black layer.
Starting at the very end, the most recent thing we think in these flows, you can clearly see a lot of erosion effect on everywhere on this. So we know that we're standing on a lot of particulate that has washed down here. If you come off like the first two primary flows, as you come down from actually go to the very top flow, it's maybe 2 meters tall and it's got all these rounded edges on it. And then there's a layer underneath of that, and Kelsey taught me this, although it should be obvious, but if you look in that layer, let's say it's a 10-meter layer maybe, and you come down just to the bottom of that 10 meters, can everybody start to see maybe softball size, like breccias maybe embedded in that?
It's just this really clear demarcation between this kind of brown and red, and then the like what we saw at our first site where we were all together, the golden pumice with the gray spots in it. And over on this side, the brown, Reid noticed something really interesting. When you lift up those plate-sized rocks that are sprinkled about, you lift them up and there's a gold piece underneath. So similar to what you guys are talking about, that gold is weathering away. Those plates may be protecting them from some of the weathering. And this side has a very different texture where this is like big pebbles, you know, 1 to 3 or 1 to 5 centimeter size that have happened up there. And so pieces of it have fallen off, and some of the really fine material is compacting into what's like the glue holding this together. And so you'll notice that there's like pumice on top and some of the black stuff on top. But then Reid got in here and poked with his stick, and you see that some of it is like embedded, and so it is forming a layer. And Kelsey made a neat comment that like 1 million years from now, it looks like it is landed upside down. But you also see that in the wall, in that kind of middle layer between the gross black stuff and the almost more traditional layer cake looking things. Can you read all these?
Okay. Are we ready? We are ready. Go. Start drawing. Plan is the first thing I want to do is just anchor myself on this map. So I was initially going to go down these easier things, come back around, work my way up here, and then check the time. See you in an hour. Have fun.
Good luck.
Alright, I'll go get the last one.
Hey, since you've got Ron, could I go? You want me to go on?
Yeah.
So we don't lose sight of these guys that we said we keep an eye on.
Yep.
Bye, college.
Way to dodge it on the way down, too.
I don't know if it'll go, but nice. It's a little big. Oh no, please. You finish her off. Oh, thank you.
Discernible crystals when you get out the Hamlins, or if it's just like green, like if it looks like crystals because of its texture, like it's bumpy.
Okay.
But I mean, like, I don't think it is crystals. If I'm answering my own question. Whoa.
Sorry.
Sorry, no, that's okay.
That's great.
Okay.
Awesome. Oh, you broke it again. Nice.
Does anyone else want to play?
So these are for, scoop is for capturing sediments. Really like your kind of everything that you see here, a representative as in kind of taking like a little square here, and that's what's representative of kind of this entire plane, or belt. But this would be attached to your tool belt and has a swing arm like this. And so you would kind of be able to do this one person. I didn't like sieve as much as I could have, but so that's half of one. I'll say the nominal expectation for a rake sample is halfway up, so that's a little bit like a quarter.
Okay.
You guys work that together.
You're doing that very close to the science station. All right, so we walk around, let's see, verbalize the macro scale description of the target, landforms, patterns, underlying unit. So we would do all of that.
First. And those are and Pahoja. Have you heard those terms before? Does anybody want to tell me the difference?
It's like the spiky stuff that you don't want to step on.
Yeah.
I'm stepping on it. That's all I know.
Okay, that's a good way to remember it. I think it's a Hawaiian word, but it's not. But it's a good way to remember. Fun way to remember it. And then Pahoja. What is Pahoja like?
Not spiky.
It's not spiky. It's smooth. And the
Safe bet.
Outside looks different.
Yep.
Yeah, that's cool.
Nice job getting that. How do you distinguish between these pillows and not pillows? Like when you have these rounded spherical features.
Yeah, now let's go to colors. That's nice to be thirsty too.
Okay.
And windy. Windy.
The tan tends to be on the ridges, and the black tends to be in the valleys and tends to be.
There's very compelling evidence that there are frozen volatiles on the cold, dark places in these persistently shadowed regions on the lunar surface. We have very compelling remotely sensed data that supports that, so enhanced hydrogen.
Subscribe for more space.